This is the second video in a series of videos about graphing trigonometric functions. In my opinion, this is one of the more challenging concepts in pre-calculus. In the first video, we focused on how to graph sine of x and cosine of x. And in this video, we will focus on graphing tangent of x and cotangent of x. Now first, I want to review what the tangent of x is. So the acronym that I use is SOHCAHTOA. So the tangent is the opposite length divided by the adjacent length on a right triangle. Okay. Now we are, for simplicity, we are thinking about these on the unit circle. That makes some things easy for us because the hypotenuse or the radius is 1. Okay. In the last video, we used, here's the angle, x, and this is going to be the opposite over the adjacent. Okay. But in the last video, we used a really convenient thing where the opposite is equal to the sine of x because we're dividing by 1. And the adjacent is the cosine of x, again, because we're dividing by 1. Now, the tangent is the opposite over the adjacent. That means that I can think about the tangent of x as being equal to the sine of x divided by the cosine of x. And that is exactly how I'm going to graph, draw a graph for the tangent of x by finding the sine of x over the cosine of x. Okay, let me write that over here so I can keep it. The tangent of x is equal to the sine of x over the cosine of x. Okay. The other thing that will be very useful for us is I think about graphs on the unit circle in that the x-coordinate is the cosine of x. I'm a little more space. Cosine of x. And the y-coordinate is the sine of x. Okay. And that'll be useful for us. Move these up here. Okay, so with that in mind, I'm going to just kind of have our angle go around the unit circle and calculate the sine of x over cosine of x, which will end up being the y-coordinate divided by the x-coordinate. And also, to keep this simple, I'm going to use some special right triangles. Okay, these should be, at least exposed to you in the past. If not, I do have a video up on my YouTube channel called 8-2 Special Right Triangles that would introduce you to these ideas. Okay, but I'm going to use these 30, 45, and 60 degree angles to get a better idea of what this graph is going to look like. So let's start. I will start off with an angle of 0 degrees. 0 degrees. And this point is at the point 1, 0. That means that the cosine is 1 and the sine is 0. So if I graph sine over cosine, it will be 0 over 1, and 0 over 1 is 0. Let me switch colors so you can see it. It's 0. Now that's a very good anchor point for the tangent of x. It goes through the origin. Okay, let me keep going. Okay, at about pi sixths, this is going to be 1/2, and this will be root 3 over 2. Now the opposite over the adjacent, 1/2 divided by root 3 over 2 is equal to the decimal approximately 0.577. Okay, so at pi sixths, I'm at 0.577, which is approximately there. Okay, let's keep going. If I move this up to about 45 degrees, or pi fourths, this is root 3, I'm sorry, not root 3, root 2 over 2, and root 2 over 2, and root 2 over 2 divided by root 2 over 2 is equal to 1. That's convenient. So at pi fourths, I'm at 1. Okay, let's keep going. Keep going at pi thirds. This is going to be root 3 over 2 and 1/2. So if I divide root 3 over 2 divided by 1/2, I get the decimal approximately 1.73. So at pi thirds, it's about 1.73, 1.7, about right there. Okay, working my way around the circle. At pi halves, or 90 degrees, the coordinate is 0, 1. And if I divide sine of x over cosine of x, I get 1 over 0, which is undefined. Not empty set. Undefined. Okay, now, I'm hoping that from your pre-calculus, learning in pre-calculus, that you realize that what happens when we divide by 0 is usually that we get an asymptote. Meaning that as this approaches 0, that I start to get very large numbers divided by very small numbers, both of which are positive. And as I divide those out, that the tangent of tangent of x is going to approach infinity. Okay? And so the graph that we get will look something like that. That's maybe not the best curve to it, but something like that where you're going off. I want to try again. It'll look something like that where it's curved. Okay? So keep in mind that there's an asymptote at pi halves, and that happens because that's where cosine is equal to 0. Okay, let me keep going around the circle. And now I'm on this side at 2 pi thirds. And this will be a positive root 3 over 2 and a negative 1/2. Okay, so I have negative x values. And so dividing root 3 over 2 divided by negative 1/2, I get a negative 1.73. So now I'm down here, negative 1.73, right about here. Okay. Now if this is about 3 pi fourths, then I have root 2 over 2 and negative root 2 over 2. And if I divide that, root 2 over 2 divided by negative root 2 over 2, I get negative 1. So I'm out here at, this is 3 pi fourths, I'm at negative 1. Okay, and if I keep going, oops, there it is, okay. This is 5 pi sixths. This is 1/2 and negative root 3 over 2. So 1/2 divided by negative root 3 over 2 is a negative 0.577. And so this point, it is right here approximately. I'm just plotting points. And this is over here, I'm at pi, I'm at negative 1 comma 0, and 0 divided by negative 1 is 0. Now notice that as I go down here, as I go into the third quadrant, that both the sine and the cosine, both the x and the y coordinates, will both be negative. So when I divide them, I will get a positive number. Okay. Now I hope that from there I can kind of simplify this graph, so not to go through every single one. But the graph will look something like this, with another asymptote at 3 pi halves. That's the next place where the cosine of x will be 0. Okay. And again, as we are in the fourth quadrant, that now the sine of x will be negative and the cosine of x will be positive. This is going to be a positive and a negative. And as you divide sine over cosine, a negative divided by a positive, it'll again be negative. And it'll be again like this. It'll have a, sorry about that. It'll again have an asymptote, and it'll hit 0 at pi halves. Yes, something like that. So that will be the graph of tangent of x. Okay, now cotangent of x will be similar, but not the exact same. So let's go back and talk a little bit about what cotangent of x is. Let me erase this. We will keep our cosine of x over sine of x. Now, the cotangent of x, the way I think of that is it's the tangent of x flipped over, 1 over the tangent of x, which, using sines and cosines, will be cosine of x over sine of x. Okay, so again, we're making up, this is made up of sines and cosines, and so it'll be a very similar looking graph. Okay, actually let me write this over on this side. The cotangent of x is equal to the cosine of x over the sine of x. Okay, so here's another graph. I will start again at 0. And at 0, the coordinates are 1, 0. And so if I divide now cosine over sine, I get 1 over 0, which is undefined. Okay, now that again means I'm going to have an asymptote along the y-axis. Okay, so I'm not sure what happens around that, but let's keep going. Come on. There we go. Pi 6, I have 1/2 over root 3 over 2. Now if I divide root 3 over 2 divided by 1/2, I get that fraction 1.73. So at pi 6, 1.73, about right there. At about pi 4ths, I have root 2 over 2, root 2 over 2, which again, root 2 over 2 divided by root 2 over 2 is 1. If I keep going up to pi 3rds, this is going to be root 3 over 2 to 1/2. And if I do 1/2 divided by root 3 over 2, then I get 0.577. 0.577. If I go all the way to pi halves, then the point is at 0, 1, which 0 divided by 1 is equal to 0. So this is a good anchor point for us for the cotangent of x, is that at pi halves it's equal to 0. Okay, I will just follow this around. At 2 pi 3rds, this is a positive root 3 over 2 and a negative 1/2. So if I divide negative 1/2 divided by positive root 3 over 2, I get a negative 0.577. Negative 0.577 is about right there. Keep going. At 3 pi 4ths, I will have root 2 over 2 divided by negative root 2 over 2, and negative root 2 over 2 divided by root 2 over 2 is equal to negative 1. And taking this around to 5 pi 6ths, this is 1/2, and this is a negative root 3 over 2. So negative root 3 over 2 divided by 1/2 equals a negative 1.73. And this is negative 1.73. And then we are at pi. At pi, which has a coordinate of negative 1, 0, which if we divide, we get negative 1 over 0. So again, we have an asymptote at pi. Okay, and I hope you understand the fact that as the angle approaches pi, that we will get, this will be small, and this will be large, but it'll be negative. And so very large negative numbers divided by a small number will give you very, very large negative numbers. Okay? And so the graph looks something like that. Okay? And as we follow this around into the third quadrant, to the third quadrant, now the sine and the cosine will both be negative. So as you divide sine over cosine, you will again get positive numbers. And at 3 pi halves, you'll again get 0. And at pi halves, will be again at an asymptote. So it'll repeat the same values, something like that. Okay, so notice that cotangent of x is kind of going down as you go across. Let's compare these two real quick. And I'm actually going to do real quick. I'm going to move this out of the way. Okay. So this is the graph of tangent of x, and this is the graph of cotangent of x. Okay, so notice a couple of things. First thing to notice is that tangent of x is kind of going up as you go across. Okay, the cotangent is kind of going down as you go across. Okay, the second thing to notice is they both have asymptotes, but they're at different places. The tangent of x's asymptotes happen. Tangent is sine of x over cosine of x. So it happens where the cosine of x is at 0. And the cotangent of x is the cosine of x over the sine of x. And we'll have asymptotes where the sine of x is equal to 0. Okay? Or you can simply memorize exactly where the asymptotes are and the fact that the direction it goes, and from there get a general idea of what these two graphs look like. So that is the end of this video about graphing the tangent of x and cotangent of x. And I thank you so much for watching.